Good day, good people. As promised, that will be diving in Laplace transform and also proving some trigonometrics. Then here's the first one. Since I said I'm gonna prove the sine AT. Now we're gonna have to use the method that says Laplace transform of ft is equals to integral e minus t f of t. So this is what we're gonna use, right? Now that means now the Laplace transform of this is just I know that you are familiar with integration. It's something that you did on your foundation on your first times. Now you cannot reach on a Laplace level when you didn't do some of integration and derivation and all with the calculus. Now here we're going to use integration by parts. We're going to use integration by parts formula, and then always know that trigonometry comes first before the exponential. So that means now we're gonna say u is equals to s on t, du is equals to a cos t, cos at, right? Then v is equals to v is equals to then v 1 over negative s. So that means here we derive, then we get the answer, and then that means here it was du over dt. Then that means we can just write dt this side. Now here we integrate this, so that means in this manner we just have to know that here we integrate, then here we derive, right? So now the rule for integration by parts says that's how we should deal with it. Now that means now we're gonna have to say u is v is right now minus v 1 over s minus s st multiplied by what is our du? Our du is a cos at dt. So that's our du. Now let me just quickly copy it this side. It's sine at divided by negative s multiplied by st. So that's how it is. Then minus 1 over s is a cos at dt, right? So 0 to infinity, right? So 0 to infinity. It's infinity 0, yeah. That's how you should know. Now here we have to deal with this using that 0 to infinity, which is now sine at e negative t negative s 0 to infinity. Then minus, here we can just take we can just say positive a s, then we will have e negative st cos at dt. So quickly let me just explain how we got to the positive. Then this and this multiply, they will give us positive, and then this one ended up to be here. Then we had something like this. We have something like this. Now here the infinity, you know very well that if ever we're saying integral from 0 to infinity, that means we have to say infinity minus, we have to substitute by infinity, then minus the substitution of 0, right? So now let us now say infinity into sine, it's going to give us 0, infinity into e to the power, it's 0. So that means now we have 0, right? We have 0, then 0 minus 0 into sine 0, 0 into this 1, but then that means it will be 1 multiplied by 0, then it will be 0. So that means here we have 0, right? So plus a over s integral of e st cos at dt, right? So now we have to now also apply the integration by parts here. We have to apply integration by parts here. Now, always cos or any trigonometry comes before the exponential. So that means it's u is equals to cos at, du is equals to negative a sine at. Then our dv is equals to e negative st. Then our v, it will be 1 over s e negative st. Or we can just take this and put it to the numerator. Then it will be easy. Now, uv minus integral of v du, right? So now here there is dt as always. Now u, it's cos at. What about our v? Our v is negative 1 over s, and then e to the power negative st. Right. So now minus, what is our v? Our v is negative 1 over s e s t. And then we have now negative a s. It's multiply. We are not subtracting it. Sine at dt. Now we also have to apply infinity and 0 here, right? So now to this one, infinity into this, it's 0. So we don't care whether cos x will allow and all, because now infinity into this, it's going to give us 0. Then 0 multiplied by whatever that the cos will give us, it will be 0. So now it will be 0. Don't forget this, right? Don't forget this, because now we're integrating this. So that means this, it's somewhere here. It's somewhere here, right? Never forget it. It's somewhere here. So now 0 minus, now 0 into this, it's what? It's 1. 0 into cos, it's 1. So that means we will have 1 over minus s. This one will allow, because 0 here gives us 1, 0 here to the exponent give us 1. So that means we are fine. Now we are fine. Now minus 1 over s minus 1 over s multiplied by, let us take this negative a out. So it's negative a. So integral e st sine at dt. Right. So now with this, we just have to know that we have what we had at the beginning. We have what we had at the beginning. So that means now this one means the Laplace transform of sine. This one is the Laplace transform of sine, because remind you, when we started here where we had this that I'm solving now, right? So now we can just say let this be something like maybe in, right? So now it's going to be like, okay, don't forget that all of this thing is equals to the Laplace transform of this. So that means we're supposed to be carrying it along, but then because of the complication, we cannot carry it along. We'll talk about it late. So that means now this one, it's equals to this, and on this one, it's also equals to what? This that we have, right? So now we're gonna have something like this, okay? Let's say I in is equals to a over s 0, just gonna be, so this negative to this, they will give us positive, so it's 1 over s. Then here this will cancel this, but then we'll still have this negative that is here, so it's a over s, right? So now e st sine at dt, right? So actually I just forgot to put this here, as we agreed on. We had an agreement that we're gonna substitute this here as we did here. So now it's I in is equals to a over s squared, right? This here, so it will be a squared over s squared, right? That's how it should be. Then here we're gonna put in, so it will be just in, right, to avoid complication. That's why mathematicians were very intelligent. We don't play. Mathematician, we try by all means to convert things and make them to be very simple, right? We can just take this to that side, so it will be plus a squared over s squared in is equals to a over s squared, right? Now we'll factor this out. A in 1 plus a squared over s squared is equals to a over s squared, right? So from there we're gonna have to divide both sides by this. I don't know if it's gonna be a good idea, but then anything for maths, now 1 plus a squared over s squared, right? So we're gonna have I in is equals to, let us just change this to something like s squared. We're doing this fraction, great, 3 there, we have learned this, plus a squared, right? We still have this at the numerator, right? Then we can just say s squared over s squared plus a squared. We were taught that we have to deal with it like that. This one will flip, this the denominator will flip, then after the denominator flipping, this one won't do anything because we're following it, right? So this will cancel this, and then we have a s squared plus a squared. So now we are done. The only thing that you have to do now is to subscribe, because now you have a full mark here. Right? So first thing first, you have to apply the principle. Then from there, you're good to go. Don't forget to subscribe, please. It's still JJ TECH Tutoring, and I'm still gonna come up with many Laplace transformation rules, and also solve for you hyperbolic functions, solve for you all of those things. Now and then with this you can also prove cos A. With this knowledge you can prove cos A, and also hyperbolic. They are very simple. Hyperbolic are the ones that are very simple to prove, because you're gonna change those into something that is in terms of e to the power negative x, e to the power negative something, and all. So with that being said, see you in the next video when we will be doing a hyperbolic function Laplace. Thank you.